In this video, I am going to find the global maximum and minimum for a polynomial function given by p of x is equal to x cubed minus 3x squared minus 24x plus 7 on the interval negative 5 to 5. So, to find the global maximum or global minimum, we need to follow the following steps. Step number 1, evaluate the function on the boundary points. So, step 1, evaluate it on the boundary points. So we need to find p of negative 5, which is going to be negative 5 whole cube minus 3 times negative 5 whole square minus 24 times negative 5 plus 7. If you evaluate it, you should get negative 73. And you can double check this work because if there is any mistake in the algebra, you should be able to figure it out. Now, we also need to find the value at positive 5, which is going to be 5 cubed minus 3 times 5 square minus 24 times 5 plus 7, and that should be equal to negative 63. So we have evaluated the polynomial function in the boundary points, at the boundary points. Now step 2, you need to find the derivative of this function. That means p prime of x and set it equal to 0 to find the critical points. So in essence, by setting that derivative to 0, you are finding the critical points. Find them. All right. So what is the derivative of p of x, which is p prime of x? There's going to be derivative of x cubed, which is 3x squared minus a derivative of 3x squared is going to be 6x. Then minus 24 times derivative of x is equal to 1. So there's going to be negative 24 plus derivative of 7, which is going to be 0. And then I set it equal to 0. So now I could divide everything in this equation by 3. Divided by 3, that's going to give me x squared minus 2x minus 8 is equal to 0. I hope you know how to factor it, but just as a refresher, I'll write it. This I could write as x squared minus 4x plus 2x. Negative 2x is negative 4x plus 2x minus 8 is equal to 0. Between these two, I could factor out x. That's going to give me x minus 4. And between these two, I could factor out 2. That's going to give me x minus 4. And that's equal to 0. I could factor out x minus 4 from each of these terms. If I did that, I'm going to get x from the first term and plus 2 from the second term, and that is equal to 0. So the product of two factors is 0, product of two numbers is 0. Either this one is 0 or that one is 0. So we don't know for sure. So if we assume x minus 4 is equal to 0, so then I get x equal to 4. On the other hand, if x plus 2 is equal to 0, then x is equal to negative. So these two are critical points. So critical points for this polynomial function. Now what we need to do, we need to evaluate the polynomial function at these 2 points. So what am I going to get for p of x is equal to 4 is going to be 4 cubed minus 3 times 4 square minus 24 times 4 plus 7. If you do the math here, I think you should get negative 73. And then we need to evaluate p of x is equal to negative 2. And that's going to give me negative 2 cubed minus 3 times negative 2 whole square minus 24 times negative 2 plus 7. And that should give you 35, I believe. Now, what we need to do, we need to look at the important numbers. So we got 4 points or 4 numbers. One associated with p of -5, one associated with p of 5, another is at the critical point x equal to 4, p of x equal to 4, and p of x equal to -4, the second critical point. So we found the values at the boundary points, we found the values of the function at the critical points. So our absolute maximum and minimum is going to stay within this set of values. So we can see the absolute maximum happens when x is equal to -2. So p of x is equal to -2 is the absolute max. Okay, 35 absolute slash global max. Global max in that interval, by the way, remember, in the interval -5 to 5. And global mean is happening at 2 different locations, at -5 and at 4, because p of x or p of x is equal to -5 is equal to p of x is equal to 4. Both of them are equal to -73, which is absolute slash global minimum. This is how you find the extreme values or global maximum or minimum for a given function in a closed interval, given that the function is continuous in that interval. So remember that the function has to be continuous in the interval and the interval has to be closed. So the steps you take is, first you evaluate the function at the boundary points, okay? And then you take the derivative, set it equal to 0 to find the critical points. Once you find the critical points, you evaluate the functions in the critical points, as I did here for x equal to 4 and x equal to -2. And then you compare both sets of value. The maximum value in 2 of these sets is the absolute maximum or global maximum for this function. And minimum value for the from this set is the absolute minimum or global minimum for the function. I hope that this discussion was helpful. Thank you very much.